So when I'm talking here and what you're receiving and what type of signal is that? Is it an analog signal or digital signal? So we're talking about analog signal and digital signal all the time. So when I'm talking to you, my voice is an analog signal. When my voice is continuous. Sometimes I have higher frequency, higher intensity. Sometimes I have lower intensity. So a continuous signal has a different amplitude. Those are like analog signals. But analog signals is very easy to be disturbed. Let's say I can talk to you in a quiet classroom, but I cannot talk to someone in the South Campus, and because my signal will get lost easily, get mixed with other sound, and get carried away with other frequencies, and people won't be able to hear. And also the amplitude decays really fast. So how can I transmit my analog signal to a further distance? For example, I want to talk to friends in Europe, and then I need to convert my analog signal into a digital signal. And this process is called digitization. And when you want to digitalize your signal, you need to do two things. One is called sampling, the other, and then we will talk about that. Okay, so an analog signal looks like this. So it's continuous, first of all, and the amplitude are changing. So I have a continuous amplitude. And I can discretize or digitalize it into some called a digital signal. So I have binary signal, for example, is one type of digital signal. Can just be 0 or 1. So when there is 1, that means I have an amplitude, which is a peak, and the 0 means I have a valley. I can define this way. I can also do modulations to digital signals, and there are two types of modulation. I think you've heard about amplitude modulation. There's also frequency modulation. So for example, I have a signal here, and I can apply another signal, is on and off signal. So I modulate the amplitude on and off. And when you receive the signal, you get on signal, on signal, and off signal. This type of like amplitude modulation are like constantly used in our infrared remote controls or in fiber communication, transmitter, receiver. And there's also frequency modulation. Like my modulation didn't do anything to the frequency of the signal. The signal stays the same frequency, means they oscillate the same way, right? I can also do so-called frequency modulation. What I do is I apply the signal, instead of making it on and off, I can make the frequency change, keep the frequency, change the frequency, keep the frequency, change the frequency. In this case, I double the frequency. So I will keep the original signal and modulate the signal for twice the frequency and keep the original signal. And all these modulation of the frequency followed my modulating signal. So this is called a frequency modulation. And the application for these are our modems, and our modems actually are using this type of modulation. And again, we know why we're doing sampling and why we are doing digitalization, because we want to actually, it's difficult to store or the exact shape of an analog signal. It's difficult to transmit an analog signal. That's why we want to digitalize our analog signal. And there are two steps when we are digitalizing it. And one step is called sampling, and the other step called quantization. So what is sampling? Sampling is you have an analog signal, so you have X and Y axis, right? Sampling is talking about how you digitalize or discretize your x-axis. So you chop up the continuous horizontal axis into discrete intervals. Right now, I'm continuously talking, but if you want to chop the time, and my voice is going to be discretized. So you will hear something, then my voice is going to be all disconnected. That's how I am sampling my voices. And this is about the x-axis. So we can also do quantization. Quantization means y-axis. So right now I have all kinds of amplitude. I have a range of voice ranges, but I can just do low or high. So these are called quantization. So you can just do 2 levels of your voice or 6 levels of your voice. And that depends on how you quantize your y-axis. So this is to chop up the vertical axis, the continuous vertical axis, into discrete levels. And then how do we do this? How fine should we sample and quantize? That depends on the signal, right? So if I want to make sure all my information was not lost, and in the X in the sampling, I want to make sure my sampling rate is high enough so I'm not losing information in between. And if I don't really care about my voice level, I can just do two types of quantization. I can just do low or high. But if my voice amplitude contains a lot of information, and then I need to quantize it a lot finer. Okay, so let's see this one, and then we can do an example. We want to digitize, means we want to sample the x-axis and quantize the y-axis. Doing this is an analog signal. It's a voltage signal. For simplicity, let's consider representing the signal with just 8 samples, meaning I will chop the x-axis into 8 pieces. So that's what I did already. And the y-axis or quantization, I will do 1 bit. So what does 1 bit mean? It's 2 to the 1. That means I have 2 signals, which is 0 and 1. Okay, so I will do two quantization and draw a line in between. So above this one is 1, below this one is going to be 0. So after I quantize it, and so I divide the axis into 8 intervals, divide the y-axis into 2 levels, and assign 0 and 1. So above this level, so it's all 1. Below this level is all 0. So after digitalization of 1 bit and 8 sampling, this is my digital signal looks like, the voltage. Okay, so how about we digitalize the same analog signal into 2-bit? So what does 2-bit mean? It's 2 to the 2, so that's 4. So my y-axis, instead of having 2 levels, now I'm going to have 4 levels. Okay, so I still keep my sampling rate to be 8 intervals, so my x-axis are chopped the same way. Now my y-axis is going to be chopped twice as much. So before I have only 0 and 1, now I have 0, 1, 2, and 3. And then, so we can actually draw lines in between now, like above this line is going to be 3, in between is going to be 2, in between of this one is going to be 1. So my digitalized signal is going to slightly change shape. So as you can see, the analog signal has a lot of information in it. Depending on how you sample or how you quantize it, you can get a very different digital signal at the end. Okay, so now let's encode what is a binary. We said we can do 1 bit, we can do 2 bit, we can use binary signals. This is how our computers are transmitting. So we can do 3 bits. Okay, so numerical 3 bits, we can do numerical signals 0 to 7. And in a binary signal, the 3 bits, what are they going to be like? So you can take about half a minute to think about it, and maybe I can ask someone to answer me. So how about 6? What is 6? So 0 is 0, 0, 0. 1 will be 0, 0, 1. Excellent. So 2 will be 0, 1, 0, right? So that's 2, because binary means 1 is 2, it's become 1 to the next digit. And then 3 will be 0, 1, 1. Excellent. And 4 will be 1, 0, 0. 5 would be 1, 0, 1. How about 6? Yes, right. Very good. So it's 1, 1, 0. And you all got it. So these are binary signal. I'm sure you have seen it many times, and these are just refreshing your memory. And so we can also do 4 bits. So now we can have more digits we can restore. And before we can only store 7 or 8 numbers, right? Now we have 4 digits, we can store 16 numbers, right? So now we can start with 0. Of course, it's 0, 0, 0, 0. How about 2? 0, 0. Exactly. 0, 0, 1, 0. 3 is 0, 0, 1, 1. And 4 is?
0, 1, 0, 0.
Yes, excellent. 0, 1, 0, 0. And how about 7? Yes. 0, 1, 1, 1. 9 is?
1, 0, 0, 1.
Yes, very good. 1, 0, 0, 1. 10 is? 1, 0, 1, 0. Excellent. And 12, 11, 12 is here. 13 is 1, 1, 0, 1. Exactly. 14 is?
1, 1.
Excellent. You got all of them. So this is how we have 4 bits, right? So you can keep adding on. You can do 5, 6, 7, and you can do 16 bits. So that's why you can have a lot of information contained. In this case, 4 bits, you can have 16 numbers in here. Okay, there's a riddle here. It's interesting. Last time we tried this, actually one student kind of figured it out. So what is round on the outside and high in the middle? Convert the analog signal below to a digital 2-bit signal for a clue. Okay, so first of all, it's a 2-bit signal. So 2-bit signal has how many levels? 2 to the 2 is 4, right? We have 4 levels, okay? So you need to do 1, 0, 1, 2, 3. So that's it. So forget about this one. So you have 4 levels on the y-axis, okay? And then they already sample it for you on the x-axis. So you can see, maybe you can spend, well, I already know the answer, so it looks very obvious to me. But if you haven't seen the answer, this one may not be that easy. If you convert it, I can give you a hint. It's all letters.
Is it per every 3 to get a 4?
It's letters. Those are all letters. Then they convert it into a word. So what is this signal here? It will be 0, right? And this signal will be 3. And this signal will be 0. Oh, sorry, this is 2. So 0, 1, 2. So 0, 2, 2, 0. And you need to kind of draw it to be able to figure out. And then 3, and then I guess it's 2, and 0, and 3, and 0, and 3, 3, 0. Did everybody get this? You have to draw it to be able to see. You got it! Oh my gosh, I'm so excited. Yes, it's Ohio. It's round on the outside and high in the middle. It's Ohio, exactly. Are you from Ohio? No, okay. It's kind of close to us. Yeah, very good. So this is just some fun things you can convert. Analog signals into digital signals. You can transmit some script to your friends and no one can actually decode. And you can tell them you can digitalize this way and sampling that way. And that's how you'll figure out my secret message next time. Okay,